Hello, welcome to Float Science News, December 5th, 2023. Now, Psyche mission to an asteroid is also carrying an interesting payload called DSOC, the Deep Space Optical Communications, which will be the first demonstration of laser optical communications beyond the moon that could help astronauts to moon mission and next giant leap to Mars. The options explored were because of the bandwidth limitations faced by the current existing deep space network. The three radio 120 degree apart three space radio satellites or transmitters on Earth, that is the Spain, Australia, and California, are already overwhelmed and cannot accommodate requests of 20%. Now this won't be serviceable by 40% by year 2030. Now they will achieve this using an optical beam as opposed to traditional RF beams. This could potentially increase the data rate by 10 to 100 times. The downside of this narrow beam width that makes communication more susceptible to misalignment, cloud cover which can attenuate the signal, and higher frequencies which are generally more susceptible to noise. Now, to test this, a generic signal would be sent from Table Mountain in Southern California, and the laser transceiver on the spacecraft locking into this beam can download this message by using a camera that counts the light particles or photons. Now, this download message is in turn relayed passed to the Page Hale telescope on Mount Palomar in California. Now, this original image sent from Southern California on the Table Mountain and this Mount Palomar would be compared for accuracy. Now, the next story would be methane capture. Although CO2 comes to mind when we think about greenhouse gases, methane is also a potent gas because it is 80 times more potent because of its molecular structure. That is despite methane only staying in the atmosphere for 12 years and carbon dioxide staying in the atmosphere for hundreds of years. This point will be more important later on in the story. Existing strategies to suppress the methane would be to fix natural gas leaks, phasing out coal, eating less meat and dairy, electrifying transportation. Other sources of methane that are impossible to eliminate are human-caused emissions produced by rice paddies and cattle farming, as well as natural sources like wetlands and Arctic. So scientists are developing new ways to remove methane directly from air. Now, CO2 has an option for negative gas captured where it is emitted and stored, but methane is a little bit more tricky because of its molecular structure, and scientists are taking different approaches. Now, the first approach would be to use naturally available microbes called methanotropes to take up more methane quickly. Methanotropes work slowly in a low oxygen environment, but by developing soil amendments and other ecosystem modifications, the microbial methanotropes can grow faster to speed up methane consumption. The second way would be to use chemical reactors close to methane sources. These reactors typically use a catalyst to speed up chemical reactions, but these requires high temperature or other stringent conditions to operate and use of expensive metals like platinum, and they do not work well in concentration of methane found in ambient air. One of the best use case for this is near coal factories where there's high concentration of methane. Another extreme approach would be to change the chemistry of atmosphere itself. Companies like Blue Dot Change have proposed releasing chemicals into the sky to enhance methane oxidation. This is done by injecting iron aerosols into the air over the ocean on a sunny day. These aerosols would react to salty sea spray aerosols to form chlorine, which would then attack methane in the atmosphere. Now, as we discussed in the first point, CO2, even though it's harmful, is less harmful than methane. The byproducts of these three processes is CO2, yes, but it's better than having methane in the atmosphere. Thank you, and until next time.